So today is our fundamental theorem of calculus. It will be fun.
Will it?
It will. Okay. We're going to make it fun. Okay. There's really nothing extra. All right. How's this? What's fun about it is we don't have to do Riemann sums for every single integral that we have. You like Riemann sums? You and Josie? Okay. You and Josie like Riemann sums. Okay. However, there will be Riemann sums that aren't nice to take, like a cosine or sine. You know, that kind of Riemann sum would be a lot different, right? Those limits would get a little bit more complicated. Okay? So here is the fundamental theorem of calculus. If a function is continuous and f is the antiderivative, so like big F is the antiderivative, then drum roll. Oh, are you really giving me drum roll? The integral from a to b of f of x dx is simply the antiderivative evaluated at b minus the antiderivative evaluated at a. Now, basically all we have to do is find our antiderivative and then plug in our limits of integration. Okay? I don't know if I ever officially defined these, but these are what we call limits of integration. Okay? That is what separates a definite integral from an indefinite integral. A definite integral has those limits of integration. Okay? So for a definite integral, we take the antiderivative and we plug in b minus we plug in a, and we get a value. That represents the area under that curve. Okay? Now, is anybody curious as to why there's not a plus c up here? Nope, didn't bother anybody? Nobody even thought about it?
Well, wouldn't it, if you're subtracting the A, wouldn't you be subtracting the C with that one too?
Very good. Okay, let's think about, oh, I'm not going to do this. Okay. So, first of all, as long as you can find the integral, or as long as you can find the antiderivative, we don't have to use the Riemann sum thing. You will have one Riemann sum on your quiz, and you will have one Riemann sum on your test. Okay? But what an integral is doing is it's adding up all of those rectangles without having to take a limit. Okay? So an integral is a way for us to sum up area. All right? Now, we don't have to worry about that plus c. Let's think about this. Earlier, if we didn't have those limits of integration, we would say, okay, we have our antiderivative plus c. All right? Now, here's a notation that you're going to need to get used to seeing. When you have your antiderivative, you're then going to need to evaluate from A to B, that slash bar, and maybe we have talked about that. That means evaluate. Okay, well, like Sammy said, if we plug in B, and then we plug in A, what's going to happen? Those C's are going to cancel. Just to be left with antiderivative of B minus antiderivative of A. So if you have limits of integration, you don't have to worry about forgetting your plus C. Okay. So let's try it out. Go ahead and write this antiderivative down, or go ahead and write this integral down. Okay, the integral from 0 to 1 of 3x squared plus 2 dx. Okay, you can see my picture here. We have a parabola, and we're finding the area underneath that parabola from 0 to 1. Now, you don't have to draw the picture if you don't want to, but that's what we are summing up with our integral. Okay. So, first step is to take the antiderivative. Okay. So, Larry, what's the antiderivative of 3x squared plus 2?
X cubed plus 2x.
Good. So there's our antiderivative. We don't have to worry about the plus c, but we need to evaluate this antiderivative from 0 to 1. Being careful of your order of operations, I would suggest when you plug in B, put it in parentheses, minus when you plug in A, put that in parentheses. So, first of all, we're going to plug in B, so your very top limit of integration. 1 cubed plus 2 times 1, minus when you plug in A, so the lower limit of integration. So we end up with 3 minus 0, which is 3. The area under that curve from 0 to 1 is 3. That saves us some time, right? Cole, you have a question?
No.
Okay. Go and write this one down. So we have the integral from 1 to 4 of 3 radical x dx. First, let's focus on the antiderivative. Alex, what's the antiderivative? You can talk through it if you need to.
Well, the power go to 3 halves.
Okay, so the power would go to 3 halves, which means we have to multiply by what? Like that? Yes. Okay, so we have the 3. The x power goes to the 3 halves, so we multiply by 2/3. What's going to happen, though, with that? Okay, those 3's will cancel. Then we have to evaluate this from 1 to 4. Okay. So what we have is we have 2 times x to the 3 halves evaluated at B minus 2 times x to the 3 halves evaluated at A.
You're supposed to get a whole number.
Huh? Well, I think we can get a nice number. Let's remember what the 3 halves power means, okay? The denominator of your exponent means root, and then the numerator means power, I guess. So 4 to the 1/2 would be, and then cube, 8, so 8 times 2 is 16, minus 1 to the 3/2 is just going to be 1, right?
Yes.
So our area under the curve from 1 to 4 is 14. So far, so good?
It's gonna get harder.
I bet it doesn't. This proved to be an antiderivative we struggled with yesterday. Logan, what's the antiderivative of secant squared? Good. So the antiderivative is tangent, and we need to evaluate that from 0 to pi over 4. Oh, good. This is where you remember some pre-calculus. Okay. So we're going to have the tangent at pi over 4 minus the tangent at 0. Joe, what's the tangent of pi over 4? And the tangent at 0?
0.
This next one, I would like you to do without my guidance. Oh my goodness, where is that X? Yeah. There you go. Thank you.
He told me I misread a question yesterday when he said integral tangent of x. He said integral secant squared of x, but it wasn't integral tangent of x. No, I got that one wrong. I think I got two
Yeah.
If you have 0,
Michael, what's the antiderivative of cosine? So we have the sine of pi minus the sine of 0. Cole, what did you end up getting?
well, 0,
Okay. I would like you to have a discussion at your table. Why did we get 0 for the area under that curve?
You know what the sine graph looks like? Yeah, the sine graph looks like this. It goes up. Equal area. Pi over 2. Or pi over 2. We're going to.
All right, 5-1. What do you think?
0.
Yeah, that's you.
0 is 0. What's this pi over 2?
Okay, so the graph has these
You
like
remember
parts
first
below
it's
and
going
below
to 0. It's pi over 2.
Okay, let's look at it.
No, pi over 2 equals 1.
The graph of cosine of x
This would be 0.
looks like this. Here's pi over 2. Here is pi. But I don't know.
Yes.
So we are finding the area under the curve from 0 to pi. So we have positive area and negative area that are going to cancel out to 0. So it's okay to have an answer of 0. All right, one more example. Go and write this one down.
Can we do this one or?
Well, no.
Split this up or something?
What?
We could like split this up. Like 1 minus 1 half.
Cole is asking, do we need to split this one up? Yes? Okay, so if we split it up, how would we rewrite it?
1 minus 1 half. Right back.
So x to the 1/2 minus 2x to the negative 1/2. Now we can take our antiderivative using the power rule. Okay, so Jake, antiderivative of x to the 1/2.
2/3 x to 3/2.
Good. Okay. Then we have minus 2 antiderivative of x to the negative 1/2. Madison, what's that one? Antiderivative of x to the negative half. What does the power become? No one. With the fractional power, it's going to stay fractional power. Like if we had the antiderivative of x squared, the power would go to. Yes. Okay. So our power would be 1/2, and then we have to multiply by the reciprocal, right? We have to evaluate that from 1 to 4. So I'm going to rewrite this to make it look nicer. We have 2/3 x to the 3/2 minus 4x to the 1/2 evaluated from 1 to 4. Okay. So we have to think a little bit, but that's okay. So we have 2/3 4 to the 3/2 minus 4 times 4 to the 1/2. Notice how I put that in the parentheses, and then we're going to subtract another set of parentheses, f of b, f of a. 2/3, 1 to the 3/2 minus 4, 1 to the 1/2. Please make sure you separate and keep together f of b minus f of a. You want to make sure your order of operations holds true, okay, especially with this subtraction. All right? 4 to the 3/2 we decided was what? 8 times 2 divided by 3. 4 to the 1/2 times 4. Okay. So we have that number minus
24 thirds.
what?
I think we should write 8 as 24 thirds instead of 16.
We'll get there. So this is 2/3 minus 4. So yes, you can think of this as 24 thirds. And 16 thirds minus 24 thirds would be what?
Negative 8 thirds minus 10 thirds. Whoa.
For a total of?
What's the 9 thirds number?
You told me 9 thirds.
Sorry, 10 thirds I meant. You get negative 6.
Okay, let's be careful here. What is 2 thirds minus 4?
Negative thirds. Positive 10 thirds.
So we're subtracting a negative 10 thirds, right?
No, you're adding it. Yeah.
Do we agree with the math now? Okay. So I'm going to give you some time to work on your assignment after I talk about our pop quizzes from yesterday.